Okay, let's try and unpack this. We're living firmly in a multi-cloud world now.
Oh, absolutely. The numbers are pretty stark, aren't they?
They really are. Like
Yeah.
84% of enterprises are already there, already using this strategy.
I think I saw it's like 98% are either using or planning to use multiple public clouds. It's huge.
Yeah, astounding numbers. And it's all driven by, well, the usual suspects, right? Flexibility, trying to optimize costs.
Getting the best services for the job wherever they are.
Exactly. And of course, trying to avoid that vendor lock-in everyone dreads.
What's really fascinating here, though, is the duality of it.
How so?
Well, multi-cloud clearly enables incredible innovation. I mean, 95% of leaders see it as a catalyst, right, for new capabilities.
Yeah.
But at the same time, it introduces some pretty significant complexities. We've seen a 67% increase in security breaches over the last 5 years.
Wow, 67%. That's a lot.
It is. And maybe the most critical point is that 80% of organizations, they admit they're innovating faster than they can actually secure this stuff.
Right. So this race to innovate, which sounds great on the surface, is actually creating these concerning gaps in security.
That's the core tension. Yeah.
And that's precisely the landscape we're here to deep dive into today.
Mm-hmm.
Our mission, really, is to explore these critical challenges, securing these complex multi-cloud environments, and reveal how advanced strategies are stepping in.
Things like AI, unified identity, and access management.
Exactly. And zero trust, how they're becoming, well, essential to bridge those security gaps.
So the goal is to equip people listening with the knowledge they need.
Right, to maintain robust security across that whole diverse cloud footprint.
Okay, let's do it.
So let's start with the appeal then. Why are so many companies making this leap? What are the tangible gains?
Well, fundamentally, it offers enormous strategic advantages. I mean, flexibility is huge.
Right.
Not being tied to one provider. And often, if you manage it right, you can actually reduce costs. Plus, you get to tap into specialized services, things like serverless functions, containers, specific databases wherever they pop up first or wherever they're best. That gives businesses a real edge.
That competitive edge.
But, and it's a big but, this power comes with a significant security challenge. The core problem is fragmentation.
Fragmentation, meaning
each cloud provider, AWS, Azure, Google Cloud, whoever, they all maintain their own distinct set of security protocols, their own tools.
Ah, okay. And these inconsistencies, these differences between providers, they can really open up vulnerabilities, can't they?
Precisely. This fragmentation, it inevitably leads to incredibly complex management situations.
I can imagine.
Yeah, think about trying to enforce a consistent security posture when every environment basically has its own rulebook. It makes it genuinely difficult for businesses to effectively secure their data, their applications.
And just by definition, multi-cloud means more, moving pieces.
Exactly. More moving pieces, which translates directly to a larger attack surface.
More potential vulnerabilities for attackers to find and exploit.
You got it.
Now, a concept that comes up a lot as a potential solution is zero trust. But I've heard it isn't natively interoperable across different cloud environments. Can you unpack that? What does that mean in practice?
Yeah, that's a really crucial point for anyone doing multi-cloud. Zero trust is a great model, never trust, always verify, super robust.
Right.
But it faces real limitations in this kind of fragmented setup precisely because each platform has its own security controls, often quite different ones.
So enforcing those zero trust policies consistently everywhere becomes tricky.
Incredibly difficult, yeah. Organizations often find they need, third-party solutions just to bridge these gaps.
What kind of gaps are we talking about?
Well, for instance, you run into what we call identity federation issues. Different cloud providers handle user management and permission authorization differently. So think about it. Your AWS IAM, that's identity and access management, which controls who does what in AWS. It doesn't natively talk to Azure RBAC role-based access control, which does the same thing for Azure.
So they operate in silos.
Exactly. You get these policy silos making consistent enforcement a real headache.
Okay, so if multi-cloud is pretty much the reality now, and it has these inherent complexities, what are the foundational things we absolutely need to get right to secure it effectively?
We can really boil it down to 3 core interconnected pillars.
Okay.
Governance, identity, and access management, IAM, and authentication.
All right, let's take those one by one. Governance.
Governance provides the overarching framework. Think of it like the strategic blueprint. It aligns all your security practices with your company policies and, importantly, with regulatory compliance.
So policy creation, monitoring compliance, risk management.
Exactly. All that strategic stuff.
And then IAM, identity and access management.
IAM is all about controlling who can access what resources, making sure only the right people have the right access at the right time.
That sounds critical. What does it cover?
Everything from user provisioning, setting up new users and deprovisioning, to managing role-based access control, RBAC, and actually enforcing specific security policies.
Got it. And the third pillar was authentication.
Yeah, and authentication is really that crucial first step within IAM. It's the process of actually verifying someone's identity before you grant them any access.
Like passwords, MFA.
Exactly. Single sign-on, SSO, multi-factor authentication, MFA, password verification, all those mechanisms.
Okay, so IAM seems absolutely central, managing who gets access to what. But how does that scale across multiple different clouds, each with its own native system?
That is precisely where a unified IAM strategy becomes not just nice to have, but pretty much indispensable.
Unified IAM.
Yeah. It centralizes the management of user identities across all your cloud platforms.
So instead of juggling separate identities and policies for AWS, then Azure, then Google Cloud, you have one place.
That's the idea. One consistent control plane for access, for security policies, even for streamlining user onboarding and offboarding. It simplifies things massively.
That concept, unified IAM, sounds incredibly powerful. You're sort of abstracting away the cloud differences. But given those differences between providers, what are the main hurdles companies hit when trying to get that true single pane of glass?
Well, the ideal is definitely that single central system, and there are multi-cloud IAM platforms that aim to deliver exactly that centralized policy enforcement. Cross-cloud controls from one interface, detailed logging for compliance, all that good stuff.
Right.
The hurdle, like you said, is the way these things are built. Cloud providers, AWS IAM, Microsoft Entra ID, Google Cloud Identity, they offer really robust native features. They're strong.
But only within their own world.
Pretty much. They're primarily designed for their own ecosystems. So the challenge isn't their individual capability, it's making them interoperate smoothly and consistently without needing complex custom integrations for every little thing.
Makes sense. And how does Zero Trust fit into this unified approach, that never trust, always verify idea? Does a unified platform actually help make Zero Trust more achievable in multi-cloud?
Oh, absolutely. A unified cloud security platform can really enhance Zero Trust implementation, profoundly so.
Oh.
Well, consider tools like CNAPT's Cloud Native Application Protection Platform.
CNAPT, so.
These aren't just single tools, they're comprehensive platforms. They actually map out the relationships between your applications, your services, your data across all your clouds.
So they see the whole picture.
Exactly. They identify potential attack paths that you'd miss otherwise. And by continuously monitoring all the connections and enforcing policies at every single level, from the user identity right down to the workload and the data itself, they significantly shrink that attack surface we talked about.
Okay, that sounds effective in theory, but does it work in practice?
Well, the data is actually pretty compelling on this. Recent trends, like from 2024 adoption surveys, show Zero Trust has something like an 80% implementation success rate.
80%? That's high.
It is, and maybe even more telling, a 75% ROI achievement. That's one of the highest among all the security technologies surveyed.
Wow.
So yeah, it really indicates that when organizations commit to a unified Zero Trust strategy, it delivers real, measurable results, even in these complex multi-cloud setups.
That's a strong case for Zero Trust. And it sounds like maybe AI is the missing piece to not just implement, but actually operationalize Zero Trust effectively and manage all this complexity. How does AI help here?
AI is proving to be a genuine game changer for operationalizing Zero Trust in multi-cloud. It makes security way more efficient, way more scalable.
In what ways?
Okay, first, AI is brilliant at monitoring user behavior and spotting subtle anomalies across all your different providers. AWS, Azure, Google Cloud, you name it.
Anomalies like?
Things that deviate from normal patterns. An employee suddenly logging in from halfway across the world, or accessing sensitive data they don't normally touch, or trying things at weird hours.
Right, things that look suspicious.
Exactly. AI constantly analyzes these activities, identifies those deviations, and can automatically trigger security protocols or ping an administrator immediately. It helps catch those secret access attempts much earlier.
Before they become breaches.
Hopefully,
right.
Yes. Second, AI models power something called user behavior analytics, UBA.
UBA?
Yeah, these process basically every interaction across all your cloud platforms. They don't just flag weird stuff, they actually determine if user activity is sticking to your security standards and flag anything that looks like risky access to sensitive info or maybe even insider threats.
Okay.
And AI also performs continuous workload trust management. It's constantly evaluating the security posture of every application, every service, making sure critical resources can only be accessed by other components that are deemed trustworthy.
That sounds pretty sophisticated.
It is. And what's truly revolutionary, I think, is how machine learning models can dynamically adjust access policies in real time.
Adjust them automatically.
Yes. So if a user's access patterns suddenly shift in a concerning way, the system can automatically tweak their access level, maybe grant them more limited permissions to sensitive data until their behavior looks normal again.
Wow. So it proactively cuts off risk from, say, stolen credentials or someone trying to grab data they shouldn't.
Precisely, without needing a human to intervene immediately.
Okay, so AI helps proactively catch threats, adapt policies. Sounds great.
Yeah.
But what about that problem you hear so much about, tool sprawl or alert fatigue? Where organizations just have too many security tools that don't talk to each other.
Ah, yes. That is a critical challenge, and it's pervasive. Tool sprawl leads directly to, inefficiency for starters. Costs go up. You get overwhelmed with the data.
Data overload, yeah.
And paradoxically, it can actually lead to more security risks because the attack surface is bigger and harder to manage coherently.
How does that happen?
Well, when you're juggling too many separate security tools, you almost always get a huge number of false positives. Just noise.
Right.
And that leads straight to alert fatigue. Security teams get bombarded, they become desensitized, and then the really critical alerts, the ones that matter, can easily get missed in all that noise.
That makes sense. And it's particularly interesting when you look back at those 2024 adoption trends. Things like automation tools and cloud SAM, security information, and event management.
Yeah, SIEM systems.
Their adoption's super high, right? 82%, 85%. But their ROI achievement is remarkably low, both just 25%. What does that tell us?
That disparity isn't just interesting, it's a really critical insight, I think.
Yeah.
It tells us that simply buying more tools isn't the answer. It's the integration and the intelligent use of those tools that actually drives value.
So the low ROI suggests it's not working well.
It suggests that tool sprawl isn't just inefficient. It creates this fog of data and alerts that makes it harder, not easier, to spot the real threat. We've even seen this pop up in places like Reddit communities, people complaining about over-automation without proper training actually slowing things down or leading to alerts just being ignored.
So the real win isn't just having the tech.
No. It comes from strategic consolidation, centralizing management, and focusing on robust analytics, not just the sheer volume of tools. The problem often isn't the tools themselves, but how they're deployed and managed or mismanaged.
Okay, so if having too many tools creates these data silos and limits visibility, how do we actually get all that separate data into these smart AI systems to make sense of it and unify our security view?
The absolute foundation, the starting point, is robust log ingestion. You need to pull in logs from your cloud-native tools.
Like CloudTrail and AWS.
Exactly. AWS CloudTrail, which logs API calls and activity in AWS, and things like Azure Log Analytics, which collects and analyzes data from Azure resources and other connected environments.
Okay.
These tools provide essential insights into what users are doing, how systems are behaving within their specific clouds.
So you gather all those logs.
You centralize them. Maybe into a unified data lake or a modern SIEM platform that can handle the volume and variety. Once that log data is centralized, then your AI models can process and analyze it effectively.
And look for suspicious activity across platforms.
Precisely. It helps you maintain consistent security policies because the AI has visibility across everything. For example, AI could detect something like privilege escalation.
Someone trying to get more access than they should.
Right. By cross-referencing log data from both AWS CloudTrail and Azure Log Analytics, it might spot someone suddenly gaining higher-level permissions across both environments, something that would look totally separate and maybe okay if you only looked at one cloud's logs in isolation.
Connecting the dots. That makes sense.
Yeah.
Okay, we've covered a lot the complex landscape, the core pillars like unified IAM, the power of AI. But for people listening, who are actively dealing with this stuff, what are the concrete, actionable steps they can take, like right now, to really bolster their multi-cloud defenses?
Right. Actionable steps. The first, very practical step is to rationalize your tool usage.
Rationalize.
Yeah, take a hard look at your current security tool set. Figure out which ones are truly essential, which ones are actually providing value, and then consolidate or retire the ones that aren't pulling their weight.
Get rid of the overlap and the noise.
Exactly. And implement a centralized system for managing the tools you keep. Deployment, licensing, maintenance, updates. Get a handle on it.
Okay, that's on the tool management side. What about the development side of the house? How do we bake security in earlier instead of trying to fix it later?
That's the whole shift left idea in DevSecOps, right?
Yeah, shift to left, yeah.
It means automating security checks as early as possible in your CI/CD pipeline. That's continuous integration, continuous delivery.
Why is that so important?
It reduces human error, catches things before they get into production, and infrastructure as code, or IAC, is absolutely crucial here.
Managing infrastructure through code.
Right. It brings transparency, consistency across all your environments. You can create reusable templates for Terraform, CloudFormation, whatever, that already include your baseline security settings and compliance logic.
So you deploy consistently across AWS, Azure, GCP, OCI.
Without rewriting the security rules every time for each cloud.
Okay.
And you can integrate tools directly into that pipeline. Things like Trivy, which is a great open source scanner for vulnerabilities. It can run automatically as part of your build process.
Catching issues early.
Okay.
And building on that, the human element. Oh, we touched on that before, but it feels absolutely critical here. How do organizations bridge that gap between having powerful tools and ensuring their teams actually work together to use them effectively across all these different clouds?
You're absolutely right. The human factor is often the make or break element. One of the biggest lessons learned in multi-cloud DevSecOps, honestly, is that culture beats tools.
Culture beats tools. I like that.
It's true. You can have the most advanced AI-powered platform in the world, but if your security teams and your development teams aren't talking to each other, if they aren't trained properly, if they don't understand the alerts or why they matter,
then the tools get ignored or worked around.
Exactly.
Yeah.
Strong collaborative communication is crucial, fostering a sense of shared responsibility for security, not just throwing it over the wall to the security team.
So breaking down those silos between teams is as important as breaking down the technical silos.
Absolutely. Maybe even more so.
Okay, beyond culture and process, is there an architectural approach that helps tie everything together and promote that interoperability we need?
Yes, definitely. Architecturally, using open APIs is key. And standardized identity brokers like OIDC OpenID Connect and Samuel.
We mentioned those briefly. They act like translators for identity.
Essentially, yeah. They allow different identity providers and cloud services to talk the same language when it comes to authentication and authorization. This promotes seamless integration and makes it much easier for your AI models to get consistent data for monitoring and decision-making.
Makes sense.
And furthermore, embracing open-source, cloud-agnostic tools is a really smart strategy.
Instead of relying only on the tools from AWS or Azure or Google.
Right. Because those native tools, while powerful, lock you into their ecosystem to some extent. If you use something like Kubernetes for orchestrating your workloads,
You can run it consistently across different clouds.
Exactly. Or use unified CI/CD solutions like GitHub Actions or Argo CD that work everywhere. For secrets management, look at cloud-agnostic tools like HashiCorp Vault.
Keeping sensitive stuff like API keys secure across clouds.
Yeah. And for security scanning, tools like UgShield for secret scanning or Trivy again for vulnerabilities and misconfigurations, these can scan across your entire infrastructure regardless of the underlying cloud.
So the mindset is kind of define security once, apply it multiple times, no matter which cloud you're deploying to.
Precisely. That directly tackles that core challenge of fragmented, inconsistent security policies across different clouds.
Okay.
And finally, maybe the capstone on all this is that consistent security relies heavily on regular policy alignment, constantly refined by AI validation feedback loops.
Feedback loops.
Yeah. Your AI models need continuous training data to learn about new threats. And the insights from the AI, what patterns it's seeing, what risks it's identifying, need to feed back into how you adjust your security policies.
It's an ongoing cycle.
Exactly. It makes your whole zero trust framework not just static, but truly responsive and adaptive to new risks as they pop up.
We have really taken a deep dive today, haven't we, into the complexities, but also the crucial solutions for securing multi-cloud.
Yeah, it's a big topic.
It's abundantly clear that while this whole shift to multiple clouds offers incredible agility, fantastic innovation, it also brings these significant inherent challenges. From that fragmented security we started with, to the overwhelming problem of tool sprawl.
And if we try and connect all these threads back to the bigger strategic picture, the journey to really robust multi-cloud security, it demands this careful, intelligent balance.
The balance between
standardized policies, automated controls, and these adaptive response mechanisms we just talked about. Things like unified IAM, disciplined zero-trust architectures, strategically integrating AI insights. They aren't just buzzwords.
No, they sound like essential frameworks.
They really are. They're frameworks you need to navigate this increasingly complex landscape. And the data backs it up, right? Zero trust shows high success rates. AI integration is growing fast because it's needed.
But the human element.
But as we kept saying, the human element, the culture, the training, and truly smart tool integration are just as vital, maybe even more vital sometimes.
So what does all this mean for you, the listener, as you're trying to navigate this rapidly evolving digital frontier?
Yeah.
It means that really understanding the interconnected nature of all these security challenges and adopting a holistic, adaptive approach.
Yeah.
It's not optional anymore, is it? It's absolutely fundamental if you want to maintain resilience.
Couldn't agree more.
So let's leave you with a final provocative thought to mull over. Given this rapid, almost exponential evolution of cloud technologies and AI, how much of our traditional security mindset still actually applies? And what truly new paradigms must we wholeheartedly embrace to secure whatever's coming next?